If you substitute for tan x, differentiation of tan x is nothing but secant squared x. Always make the coefficient of x squared as 1. Integral of dx divided by a squared minus x squared under the root, which is given by the formula sin inverse of x by a plus c. X squared plus a squared integral gives you 1 by a into tan inverse of x by a plus c. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. So in the last session, we have learnt many problems on some particular functions of the integration. Now in today's session, we are going to have your session number 9, dear students. And here, chapter number 7 called Integrals. And what are all the topics we are going to study under this session is nothing but some more problems related to a particular functions we are going to have. And without any delay, let us revise to the formulae which we are going to use it in the problem. So the formula is given by like this: integral of dx divided by x squared minus a squared is nothing but 1 divided by 2a into log of modulus of x minus a divided by x plus a plus c. And then integral of dx divided by a squared minus x squared is given by 1 divided by 2a into log of modulus of a plus x divided by a minus x plus c. Similarly, integral of dx divided by a squared plus x squared or x squared plus a squared is given by 1 by a into tan inverse of x by a plus c. So similarly, if you are having under the root, then you are going to have integral of dx divided by under the root of x squared minus a squared is given by log of modulus of x plus under the root of x squared minus a squared plus c. Similarly, if you are having under the root of a squared minus x squared, you are having sin inverse of x by a plus c. So under the root of dx divided by a squared plus x squared, then log of modulus of x plus under the root of x squared plus a squared or a squared plus x squared plus c. And these are all the formula you have to remember to solve the problem, dear students. And you know how to do completing the square. Now let me move on to the questions what they've asked. Integrate x squared divided by under the root of x to the power of 6 plus a to the power of 6. Dears, you are having in the numerator x squared. Let us write this problem symbolically. You are having integral of x squared divided by under the root x power 6. I am writing it as x cube whole squared because differentiation of x cube gives you 3x squared. So numerator automatically we are getting plus a power 6 as it is. I am writing a power 6 can be written as a power 3 whole squared into dx. Now here I am taking the substitution method, like let put x cube is equal to t. Now differentiate this with respect to x. If you differentiate this with respect to x, you are going to get it as differentiation of 3x cube is nothing but 3 into x squared is equal to dt divided by dx. Otherwise 3x squared into dx is equal to dt. Now substituting here, do not 3x squared because you are having x squared dx, therefore you can substitute as x squared dx is equal to 1 by 3 into dt. Now you can substitute this. So therefore you are having integral of x squared into dx is nothing but 1 by 3 into dt. Observe here, divided by under the root of x cube. We have substituted as t squared plus a cube whole squared. So where a is nothing but here a constant. Now you can have your t squared plus a cube whole squared is nothing but you are getting it is according to the formula dx divided by under the root of a squared plus x squared is given by log modulus of x plus under the root of a squared plus x squared plus c. So writing accordingly, you are getting, remember 1 by 3 is outside, log of modulus of either t replaces x, so t plus under the root of a squared replaces a cube whole squared plus t squared plus c. Substituting back to c, 1 by 3 into log of modulus of t is nothing but we have substituted as x cube plus under the root of a cube whole squared plus x cube whole squared plus c. And this is your final answer. You are going to get it as. I hope you understood this one. Now we'll be moving on to the next problem. What they've asked. Integrate secant squared x divided by under the root tan squared x plus 4. Dears, if you substitute for tan x, differentiation of tan x is nothing but secant squared x. So therefore, here I am going to write it this symbolically first. Secant squared x divided by under the root of tan squared x plus 4 into dx. So, I am going to take here, let tan x is equals to t. That is substitution method. Now, differentiate this with respect to x. If you differentiate this with respect to x, you are going to get it as secant squared x is equal to dt by dx. Otherwise, secant squared x into dx is equal to dt. Now, therefore, you can substitute the numerator as dt in the given we have, which implies secant squared x into dx as dt divided by under the root of tan squared. Tan x is nothing but t, so t squared plus 4 I can write it as 2 squared. Dear students, this is of the form integral of dx divided by under the root of x squared plus a squared, which is nothing but log of modulus of x plus under the root of x squared plus a squared plus c. So accordingly, a replaces here 2 and x replaces here t. Therefore, writing in the form of that itself, which implies log of modulus of x replaces t plus square root of t squared plus a squared plus c. Now substituting back to c, you are going to get the answer log of modulus of t we have substituted as tan x. So tan x plus square root of t we have substituted tan squared x plus 2 squared is nothing but 4 plus c. And this is your final answer. You are going to get it as. I hope you understood this one. Now we'll be moving on to the next problem, dear. What they've asked. Integrate 1 divided by under the root of x squared plus 2x plus 2. Now dear students, denominator it is not in the form of x squared plus a squared or x squared minus a squared. Now reducing to that form by completing square method. Now take whatever under the root, that is x squared plus 2x plus 2. Now observe that coefficient of x squared must be 1. Yes, here coefficient of x squared is nothing but 1 you are having. And then after that you are going to see what is coefficient of x. Coefficient of x is nothing but 2. Half of 2 will be is equal to 1. So half of 2 is equal to 1 by 2 into 2, which is equal to 1. So whole squared of that one, adding and subtracting. So 1 squared is nothing but 1 only. Therefore writing x squared plus 2x plus 1 squared minus 1 squared plus 2. I hope you got this one. Now if you observe, dear student, this is a squared plus b squared plus 2ab. Therefore this I can write it in the form of x plus 1 whole squared. Minus, see here you are having minus 1 squared plus 2. 2 minus 1 gives you plus 1 only, which can be written as 1 squared. Therefore, I can reduce this x squared plus 2x plus 2 as by completing square method x plus 1 whole squared plus 1 squared. Now writing that denominator, which implies integral of dx divided by under the square root, this can be written as x plus 1 whole squared plus 1 squared. Now here, this is according to the formula related to this one, integral of dx divided by x squared plus a squared, which is nothing but log of modulus of x plus under the root of x squared plus a squared plus c. Now therefore here x replaces x plus 1 and a replaces 1. I hope you got this one. Now relating that and writing as it is, log of modulus of x replaces x plus 1 plus under the root of x replaces x plus 1 plus a replaces 1 plus c. So, and this is your final answer. You are going to get it as. What they asked next problem. Integrate 1 over 9x squared plus 6x plus 5. So therefore denominator it is not in the form of x squared plus a squared. Reducing to the form of that by completing square. So here let me take whatever they given, 9x squared plus 6x plus 5. Now you have to make the coefficient of x squared as 1. To make it as 1 you can take 9 as common factor here. X squared plus 6 by 9 will be divided plus 5 by 9, isn't it? Now 9 will get cancelled, 6 second only. 9 will get cancelled, 5 only will be remaining. Now here, after making the coefficient of x squared as 1, observe that what is the coefficient of x, which is 6 by 9. Half of that, see, half of 6 by 9, which will be 2 1s are 2 3s are 3 1s are 3 3s are, which is 1 by 3. That whole squared. Now adding and subtracting that squared, what happens? 9 into x squared plus 6 by 9 into x plus 1 by 3 whole squared minus 1 by 3 whole squared plus 5 by 9. I hope you understood this one. Now 9 into this you can observe, dear students, a squared plus b squared plus 2ab, isn't it? So therefore 2ab gives you here 1 by 3 only. So you can have x plus 1 by 3 whole squared, isn't it? Minus c plus 5 by 9 minus 1 by 3 squared is 1 by 9. So therefore you are having 9 into x plus 1 by 3 whole square plus 9 will be the LCM here. 5 minus 1 is nothing but 4. So which can be written as, you can write this one as 9 into x plus 1 by 3 whole squared plus 4 by 9 can be written as 2 by 3 whole squared. I hope you understood this one. Now writing here integral of dx divided by 9x squared plus 6x plus 5, which will be is equal to, you can observe, dear students, this we are writing 9. So denominator it is there. So therefore 1 by 9 will be outside the integral. Dx divided by 9 is already here. So writing x plus 1 by 3 whole square plus 2 by 3 whole squared. Now this is in the form of integral of dx divided by x squared plus a squared. X squared plus a squared integral gives you 1 by a into tan inverse of x by a plus c. Right? So here a replaces 2 by 3 and x replaces x plus 1 by 3. Writing as it is, which implies 1 by a is 2 by 3 into tan inverse of x replaces x plus 1 by 3 divided by a is 2 by 3 plus c. Now which implies 3 will go to numerator, 3 by 2 into tan inverse of, simplifying the numerator, 3 into x plus 1 divided by 3 whole over into 3 by 2. I am writing denominator as the numerator. Now which implies 3 by 2 into tan inverse of, see here 3 will get cancelled, remaining is 3x plus 1 divided by 2 plus c. And this is your final answer, dear students. I hope you understood these steps and reducing by completing square method. Now we'll move on to the next problem. What they've asked, integrate 1 divided by under square root 7 minus 6x minus x squared. Now dear students, take whatever there inside the square root and reducing to the form of x squared minus a squared or a squared minus x squared or x squared plus a squared by completing square method, right? Now take the inside term, which is 7 minus 6x minus x squared. Now I want to make the coefficient of x squared as 1. So taking negative 1 common. By taking negative common, you can have x squared here plus 6x plus 7 is there, minus 7. I hope you got this one. Now after making coefficient of x squared as 1, see that what is the coefficient of x? Coefficient of x is 6. Half of that. Half of 6. Half of 6 will be 2 1s are 2 3s are, which will be is equal to 3. That is square. So therefore, adding and subtracting these 3 squared, x squared plus 6x plus 3 squared minus 3 squared minus 7. Now therefore, you are getting this, it is in the form of a plus b whole squared, which is x plus 3 whole squared. So here minus 3 squared minus 7 squared, which is minus 9 minus 7. So therefore, you are having minus of x plus 3 whole square minus 9 minus 7. You are going to get it as minus 16. Correct? So multiplying minus and what happens there? First 16 will come. 16 minus of this x plus 3 whole squared. Otherwise 16 can be written as 4 squared. Therefore writing this one under the root, integral of dx divided by under the root of 7 minus 6x minus x squared can be written as integral of dx divided by 16 is nothing but 4 squared minus x plus 3 whole squared. And this is in the form of under the root, isn't it? Which is in the form of integral of dx divided by under the root of a squared minus x squared. Now under the root of a squared minus x squared is given by sine inverse of x by a plus c. So sine inverse of x by a plus c means x replaces here x plus 3, a replaces here you're having 4. So therefore writing accordingly, which implies sine inverse of, that is I am writing here problem dx divided by 4 squared minus x plus 3 whole squared can be written as sine inverse of x replaces x plus 3 divided by a replaces 4 plus c. And this is your final answer. You are going to get it as dear students. I hope you understood these steps also. Now we'll be moving on to the next problem, dears. What they've asked. Integrate 1 over under the root x minus 1 into x minus 2. Dear students, you can multiply this inside. What happens? X minus 1 into x minus 2. I am taking this separately because I am going to get here quadratic equation, and by completing square method reduce to the form of any one of the particular function. X into x is x squared. So you are having x into minus 2 is minus 2x minus 1 into x. Again minus into minus plus 2. So therefore x squared minus 2x minus x is minus 3x plus 2. So now this is not in the form of either any particular function. Now reducing to that form, first observe coefficient of x squared is 1. Yes. Now you have to observe what is the coefficient of x? 3. Half of that. Half of 3, which is nothing but 3 by 2. Whole squared, 3 by 2 whole squared you are taking. So adding and subtracting, x squared minus 3x plus 3 by 2 whole squared plus 2 minus 3 by 2 whole squared. Now you can have, which is in the form of x minus 3 by 2 whole squared. Here you can have plus 2 minus 9 divided by 4. Now you can take LCM as 4 there, so which will become x minus 3 by 2 whole squared. Now plus 4 2s are 8 minus 9 divided by 4. So which implies x minus 3 by 2 whole squared. Now 8 minus 9 is nothing but 4 minus 1 by 4, which can be written as x minus 3 by 2 whole squared minus 1 by 2 whole squared. I hope you understood these steps. So therefore, writing this in terms of integral of dx divided by this, I have reduced to the form of here x minus 3 by 2 whole squared minus 1 by 2 whole squared under the root. Be careful here. So if you are having under the root, you are getting integral of dx divided by under the root x squared minus a squared is given by log of modulus of x plus under the root of x squared minus a squared plus c. So x replaces x minus 3 by 2 and a replaces 1 by 2. Writing in the form of that, which implies log of modulus of x replaces x minus 3 by 2 plus under the root of x minus 3 by 2 whole squared plus a squared is, you are getting minus a squared, that is minus 1 by 2 whole squared plus c. And this is your answer. You are going to get it as. I hope you got this one. Now dear students, if you reduce this in the form of that, you are getting the same answer, x squared minus 3x plus 2. Therefore, aram se you can write log of modulus of x minus 3 by 2 plus you are getting under the root of x squared minus 3x plus 2 plus c. And this is your final answer. You are going to get it as. I hope you got this one. Now we'll be moving on to the next problem, dears. Integrate 1 divided by under the root of 8 plus 3x minus x squared. Now taking same and by completing square method, 8 plus 3x minus x squared can be written as minus of x squared. Here it is nothing but minus 3x minus 8. Now coefficient of x squared I made it as 1. Now taking coefficient of x as which is 3, half of that. So 3, half of 3 which is nothing but 3 by 2 whole squared. Now which is minus of adding and subtracting that x squared minus 3x plus 3 by 2 whole squared minus 3 by 2 whole squared minus 8. Now this will become minus of x minus 3 by 2 whole square. Now you are having here minus 9 by 4 minus 8 which is minus of x minus 3 by 2 whole square. Now this will become minus, see, minus 9 minus 8 fours are which is 32, isn't it? Divided by 4. So therefore, minus 9 minus 32 which is nothing but x minus of x minus 3 by 2 whole squared minus, you are getting 32 plus 9 is nothing but 41 divided by 4. Now you can multiply minus sign inside. 41 divided by 4 minus x minus 3 by 2 whole squared. Otherwise, you can write this one as root 41 divided by 2 whole squared minus x minus 3 by 2 whole squared. Now, under the root writing that integral of dx divided by, this can be reduced to the form of this 41 divided by 2 root whole squared minus x minus 3 by 2 whole squared under the root. So, therefore, it is in the form of integral of dx divided by a squared minus x squared under the root, which is given by the formula sin inverse of x by a plus c. Right? Now, x replaces here x minus 3 by 2 and a replaces here root 41 by 2. So, writing that one which implies sin inverse of x replaces here x minus 3 by 2 divided by a replaces here root 41 divided by 2. Now, therefore, simplifying further, sin inverse of taking LCM as 2, 2 into x is 2, x minus 3 divided by 2 whole over root 41 divided by 2. Now, 2 will get cancelled. You are going to remain with sin inverse of 2x minus 3 divided by under root 41 plus c. And this is your final answer, dear students. I hope you understood this one also. Now, we'll be moving on to the next problem. What is that? Integrate 1 divided by under the root of x minus a into x minus b. Now, same as we have done in the last case, take x minus a into x minus b. Now, multiply this, x into x is x squared minus bx minus ax plus ab. Minus into minus is plus ab. Now, you can take here x as common, x squared minus, you are getting b plus a or a plus b into x plus ab, plus ab, right? You are getting. So, therefore, you can have here, observe the coefficient of x squared must be 1. And what is the coefficient of x? A plus b, half of that, half of a plus b, that whole squared, okay? So, therefore, adding and subtracting that is x squared minus of a plus b into x plus a plus b divided by 2 whole square plus ab minus a plus b divided by 2 whole squared. So, now you can write this is in the form of x, minus is there, minus of a plus b divided by 2 whole squared, right? Now again simplifying this, plus AB minus A plus B whole squared, A plus B whole squared divided by 4. Now again simplification of this, let me write it here, x minus of A plus B divided by 2 whole squared. Now plus AB, that is 4AB, taking LCM, 4AB minus expanding that, you are going to get A squared and multiplying minus sign, that is A plus B whole squared, which is A squared plus B squared plus 2AB, multiplying minus sign, which is gives you minus A squared minus B squared minus 2AB divided by 4. Now again writing this one, x minus A plus B divided by 2 whole squared. Now this will become 4AB minus 2AB, which is nothing but plus 2AB. Therefore, you can have plus 2AB minus A squared minus B squared divided by 4. Now if you take minus sign common, you can have x minus A plus B divided by 2 whole squared, right? So you can have this one will be, if you take minus sign common, A squared plus B squared minus 2AB, which is in the form of A minus B whole squared. So A minus B whole squared divided by 2, which can be written as A minus B whole squared divided by 2 squared is nothing but 4. I hope you got this step. Now writing this here, you are getting integral of dx divided by under the root of, you are having x minus A plus B divided by 2 whole squared, right? Again minus A minus B divided by 2 whole squared. I hope you understood this step. Replacing this as here, what we have reduced according to the completing square method. Now this will be giving you integral of, what is that? Integral of dx divided by under the root of x squared minus A squared, giving you log of modulus of x plus under the root of x squared minus A squared plus c. Therefore, writing in that form, you can have, and x replaces here x minus A plus B by 2 and A replaces here A minus B by 2. So, therefore, which implies log of modulus of x minus of A plus B divided by 2 plus under the square root of, if you are reducing to that form, x minus of A plus B divided by 2 whole squared minus A minus B divided by 2 whole square plus c. Now again reducing to the form of log of modulus of this, you can have x minus A plus B by 2 plus this, you can write aram se what we have reduced to the form of this. So therefore you can have x squared minus of A plus B into x plus AB plus c. And this is your final answer. You are going to get it as dear students. I hope you understood all the steps of the exercise 7.4 what we have solved till now. Now still more problems you are going to have in that exercise. So thank you dear students. I hope you enjoyed this session. I hope you understood how to solve the problems based on those particular functions. In the next session, we'll be solving some more problems on that formula itself. Keep watching. Have a nice day, dears.